The smart thing to do is to develop superior AI solutions, but without working very hard for it. Is it possible? I think it is, with AI. My name is Ronen Talbotzer. For many years I've been working in AI, developing various tools, various products. A few of them were even superior. And during this time I collected many practical tools, many productive approaches to do it in a very cost-effective way. This will be the topic of our course. It's actually a meta course, a trilogy of 3 courses. The first course is from basic Python to genetic algorithms. Welcome! But there are 2 other courses. The second course is machine learning for a fantastic subject, medical data mining. And lastly, the third course in this trilogy is deep learning and evolutionary computation. Now, the students that take these courses for the degree need to take into account that each course has 2 sections: lectures and practice lessons. It is applicable for all 3 courses, course number 1, course number 2, and course number 3. So then again, we are in course number 1, and this is lecture number 1, Introduction. At the top row, you can see the name of the meta course, the trilogy, and the course we are now at, course number 1. And in the second row, you will see the number and the name of the lecture, now it's Introduction, with the topics, the chapters for this lecture. So today we have 5 topics: about, goal, method, course units, and Google Colab. And this is, of course, the About chapter. Now you may ask, what is this bar on the left? This is the methodologies bar. It lists several methodologies that will stay without throughout the course. The topics change, of course, from one lecture to another, but these subjects, these methodologies, they touch almost every topic, and therefore they will stay with us. And when the time arrives, I just turn on the relevant methodologies. You will see very soon. So without further ado, let's move to the goal. The goal of the course is to acquire programming and algorithmic skills, but with a special emphasis on genetic algorithms. Why? Because genetic algorithm is one of the most productive approaches to developing superior AI solutions. So the course begins with basic programming with a very definite goal to enable us to develop these genetic algorithms that will help us develop superior AI solutions. We will go later, of course, more in depth about genetic algorithms, but I like this cartoon. This is a picture that says it all. The genetic algorithm is a way to simulate evolutionary processes, and we use this kind of simulation in order to tune AI systems. This is only one example of what genetic algorithms can do to AI. We will, in the third course, talk more about it. Next, let's talk about the method. So, Python is a great language. I don't think I need really to explain how popular it is, how professional it is. And we will use Python as our main programming language, although the main principles apply to many other programming languages. If you want to learn Python, you can go online to python.org. This is a great starting point to learn this amazing language. But you don't really need to, because I will drive you through this. And again, aim for the concrete goal of developing genetic algorithms. But let's not forget another important issue, which is computational thinking. Computational thinking is a very important skill that we need in everyday lives, but of course also in computer science and in the developing of superior AI solutions. We will talk a lot about computational thinking, and this also touches many of these methodologies. At the heart of computational thinking is the algorithm. What is an algorithm? It's a way to solve a problem, and Professor David Mellon from Harvard University gave a wonderful example of what a good algorithm is. In his class, he invited two students to come to the stage and gave them two old phone books. Their mission was the same, to find the number of a certain individual. However, the process they used, the algorithm, was different. One student needed to go page by page, scan each page, until he finds the name of that particular individual. While the other students used a different method. He just opened the book in the middle, looked at the name at the top row, and then had to figure out whether the name he was looking for is before the central page or after the central page. Then the magic happened. The student needed to tear up the book into two halves, throwing away the irrelevant half, and then doing the same algorithm only for the half that remained in his hands. So, in the second time, he had only half of the problem. In the third time, only 1/4 of the problem. And in the third time, 1/8 of the problem. And so on. Now, of course, they made a competition, and you can guess who won. What a wonderful way to explain what is algorithm. In this particular case, this algorithm is called binary search. But the algorithm today is not the only thing. We live in the age of big data, and data is another player in the world of AI. In this course, we will see how to work with data, how to let genetic algorithms work with data, and surround everything with AI. Okay, so if data is so important, what about the data of this course? Well, I took it from the best. Professor Benny Shor and Dr. Amir Rubinstein from Tel Aviv University created an award-winning method to teach Python. Their method was published in the academic literature, but they were very generous, and many of the slides that I will show in this course actually was made by them. These are the topics of the lectures. We will begin with basic programming, move on to data analysis, then to algorithms, and finally to genetic algorithms. For the practice lessons, we will use three products. One is the Google AI platform. The second is Google Colab, which is a way to develop code in the cloud. And the third is Jupyter Notebook, which is a format of how to write code in a very efficient way. This way makes perfect sense when working with data and data science. So let's begin with the first tool that we will use in this course, called Google Colab. We go to colab.research.google.com, and this is the page we get. Already here you can see a nice tutorial, which you are welcome to review on your spare time. Nonetheless, I will now just give you the gist. Google Colab is an IDE, which stands for Integrated Development Environment, which means you can write code and execute it in the same environment, but even more so, everything is done in the cloud, which is accessible through your browser. Thanks to the fact that it's in the cloud, you can also access fast processors like GPUs. In this tutorial, you can see even some very simple examples of Python code. Here, for example, is a calculation of the number of seconds in a day. So, seconds in a day is actually a name of a variable, that's a piece in the memory of the computer, into which we assign a value, and this value equals 24 times 60 times 60. This is the first example that Google used, so let's now try to make our own code with a very similar example. I click File, New Notebook. First of all, I will give it a name. Let's call this file with the name of the course, Python for Genetic Algorithm, and add the number 111. Now what you see is a first blank page of a notebook. A notebook is the place where we write the code. We can also add some annotation about the code, run it, see the output, and store the output. Let me show you how. Every notebook page is a series of cells. These cells are from two kinds, either code cells or text cells. The code is for the Python commands that we will write, and the text is not less important, it is for the annotations, for the explanations that we will add to the code in order to make it more readable. So let's write our first code here. We will do something very similar to the example you've just seen. We will say that a variable named x equals 5. In order to run this code, we will click this Run button. This may take some time, as for the first run, Google Colab turn on a new machine in the cloud. So, the running is complete. We get this green V. Well, nothing happened. This is okay because the only thing that we've done till now was just to allocate a new variable called x and assign a number into it, which is 5. If we want to see some output, for example, the very value that we just put into x, we will need to use the print command, like so. We will run it again. And now we received our first output. Let's add another variable. We will call it y, and we will say it is 3. And we will print it as well. Now let's try, just for the fun, to replace the values between x and y. We will say that x equals y. And again, print x and print y. Let's run it. Okay, so the first two rows are the first prints, which were 5 and 3. They are kept 5 and 3. And then we make the swap here and printed x and y again. And as we can see, now both of them equals 3. Do you know why? This is because in this assignment command, denoted with the equal sign, the value that is written from the right side of the equal sign just goes into the variable that is written on the left of the equal sign. So now y, which is 3, was put into x. And indeed, the third print command resulted in 3. However, we didn't say that what was in x should be in y. If we want to do that, maybe we should write something like this and run it again. It didn't work because it was already too late. X after this line is already 3. When we reach this line, it doesn't remember that it was used to be 5. So in order to solve this problem, we need to allocate a temporal variable. Let's call it temp. And first of all, we will put the value of x there, then change the value of x, and use the temp value to put it in y. If we run it now, voila! 5 and 3 became 3 and 5. We will see many more examples of Python programming, of course, and on how to use Google Colab. For now, I would like to leave you with a nice exercise. Can you swap the values between x and y without using a third variable? Think of it, and the solution comes in 3, 2, 1. Here it is. Do you understand why it works? Well, we will get the full context in the following lecture. See you soon.